Okay, let's look at one more example of solving 3 equations and 3 unknowns. So we're going to approach it the same way. Let's number our equations first. So 1 is x minus y minus z equals 1. Equation 2 is negative x plus 2y minus 3z equals negative 3. And equation 3 is 4x minus 3y minus 8z equals 2. Okay, so we're going to, we have 3 x's, we have 3 y's, and we have 3 z's. So there's not any particular one that we would want to eliminate more than the others. But when I do look at these, the coefficients, I think x would be one of the easiest to eliminate because, you know, these are already ready to eliminate in equations 1 and 2. And then in 2 and 3, we could just multiply maybe by a 4 for equation 2 and eliminate the x's really easily. So let's do that. So let's write down what we're going to do. Eliminate x from 1 and 2 first. Okay, and then let's do it. So all we have to do for equations 1 and 2 is write the equations and then add them together. Don't skip this part where you're writing the equations down because in this process, it's actually a pretty simple, straightforward process, but it's so easy to make a little error, a little sign error, or a numerical error. And so the more that you write down and show your work, the easier it is to find those little errors. All right, so the x's are eliminated. The y's are negative y plus 2y, which is y. And the z's are negative z plus negative 3z, so that's minus 4z. And that's equal to 1 plus negative 3, which is negative 2. Okay, great. Let's number that equation number 4. Okay, now we're going to eliminate x from equations. Let's do equation 2 and 3. Okay, we can do 1 and 3 or 2 and 3, but remember we need to get that equation 3 involved. So if we're going to do 2 and 3, it looks like we should just multiply this second equation by 4 to get opposite coefficients for x. So if we multiply the second equation by 4, that's negative 4x plus 8y minus 12z is equal to negative 12. And then equation 3 is just 4x minus 3y minus 8z is equal to 2. Then we're going to add those two equations together, eliminate the x's. The y's are 8 plus negative 3, which is 5y. Negative 12 plus negative 8 is negative 20z. And negative 12 plus 2 is negative 10. Okay, so this is our equation 5. So remember, now we have equation 4 and 5 with no x. It just has a y and a z. So we have 2 equations, 2 unknowns, and we can move on. So now we're going to eliminate, well, let's see, we have y or z. I personally think y looks easier because we have a y by itself and then a 5y. So let's eliminate y, and let's do it from equations 4 and 5. Okay, so for equation 4, it looks like we need to multiply that equation by negative 5 in order to create that opposite coefficient on y, negative 5y and positive 5y. So when we do that, negative 5y, negative 5 times negative 4 is plus 20z, and negative 5 times negative 2 is equal to positive 10. Write equation 5 down, 5y minus 20z, oh, interesting, equals negative 10. Okay, so you're probably noticing that when we add these together, you're getting 0 on the left and 0 on the right. Uh-oh, okay, so that is a true statement. And so that means that there is a solution. There are infinitely many solutions, but we actually have to define those solutions. Okay, so what we have to do, let's see, we need to write two of the variables in terms of the other variable, and then the third variable can be all real numbers. So this is the part that's a little bit tricky when you get these in your homework. These are the hardest ones to solve. The good thing is you can actually solve for any of the variables. You just need to solve for the same one. So what I would say is I would probably solve maybe like solve number 4. So equation 4 is y minus 4z equals -2. So that would be really easy to solve for y in terms of z. So y is equal to 4z minus 2. Okay, so that is y in terms of z. What that means is we also need, now we need x in terms of z. Okay, because then both of x and y will be in terms of z, and then z will just be all real numbers. Okay, that's just the way it worked out. In this case, I thought that was the easiest way to go. You probably want to look at equation 4 and 5 to start this process. Now, to find x in terms of z, let's go to equation 1. Okay, that's x minus y, but we don't want to write y. We want to write 4z minus 2 for y, what we just found for y, and then minus z equals 1. What that's going to do is we can solve for this x, and it will be in terms of z. Okay, that's why I think this is the most complicated part, because you've got to go back to the beginning of your problem, right? Because we don't have x in terms of z right now. So you have to substitute in the y that is in terms of z. All right, now that's x minus 4z minus 2 minus z equals 1. I'm glad I write those little lines on the z's so I don't confuse them with the 2. Okay, so I got x minus 5z, and then I could just add this 2 over to the other side, 1 plus 2 being 3. So x is equal to 5z plus 3. Okay, so let me go through and find those answers again. I need this answer and this answer. Okay, so my final solution I'm going to write like x, y, z such that x equals 5z plus 3, y equals 4z minus 2, z equals all real numbers. Okay, so I have to have both of those parts done before I can write the final solution. And now before we go, I want to show you the diagram, let's see, here, of how these 3 parts look. So let me go and look at make this as big as possible. Okay, so as it says, just like a system of 2 equations containing 2 variables, system of 3 linear equations containing 3 variables has exactly 1 solution. This is what it looks like when you have 3 variables. So what that creates instead of a line is it creates a plane. And so what we have is 3 planes, and they intersect in 1 point. That was the first problem we did, where we got x, y, and z to be numbers. That's called a consistent system, and it has 1 solution. Okay. Now, there are 2 options for a consistent system with an infinite number of solutions, and that's actually what we just saw in this problem. So it is still consistent because there is a solution, and I believe this one would look like this. It'd be like the pages of a book where they intersect, that they create a line. And as you can see in as you just saw in our answer, we had x equals 5z plus 3 and y equals 4z minus 2. Well, those are lines described here. If we ended up getting solutions that were all the same page, all the same plane, then that might look even slightly different. And then finally, you have two choices for no solution. So remember the second problem we did, there was no solution. We don't really know which solution it was, but it's called an inconsistent system. And either it was like three separate floors of a building that never touch, right? Or it was three planes that do intersect each other, but not all in one place. So here's an intersection of two of the planes, here's an intersection of two of the planes, here's an intersection of the two of the planes, but they don't all touch together. So I hope that this diagram helps you visualize a little bit what's happening. And make sure that you do write down that vocabulary of consistent, that has a solution, and consistent with infinite number of solutions, or an inconsistent system with no solution.